Okay, this question was a little bit of a problem-solving question, all about roots. So they're giving us some information, and we've got to solve completely this. Basically, find the roots of these two equations. So you might think, let's start out. Let's call that roots of this one alpha and beta. Um, Now, before I name the roots of g, it says at least one root on the imaginary axis. So that means if it's on the imaginary axis, it must be the form ai. This is a cubic equation, and we're told that m is real. That means there must also be another root that's negative ai, because it's going to have to come as a conjugate pair. So for this one, I'm going to call them ai, negative ai, and then you can pick whatever you like for the last one. So we could call that one gamma. Right, so now is a case of writing down all the facts we know. We know the sum of the roots of f is equal to the problem of roots of g. Okay, so by working through that, we can get this equation here. So we've used these two bits of information. Now we're going to go to know what we know about roots. Well, what do we know about alpha times beta? So alpha times beta is going to be c over a. So that's going to be that. We can also get that alpha plus beta is going to be negative b over a. We can also get from the other expression that the sum of those roots is going to be 2 over m, and that's going to simplify. And we can also get, if we do the product of the roots, so we know the product of the roots of the cubic g is alpha squared gamma, because we already worked that out up here. And that's going to be equal to negative b over a. Oh, I've just written e, so gamma. That's because I changed from my working to this. Right. So we can now get, if we combine these two, we've got alpha squared times gamma, where we know that gamma is 2 over m, is equal to 9 over m. So we can cancel all that out, and we can, sorry, that was a squared. We can get that a squared is 9 over 2. So a is 3 over root 2. And now we've started managing to solve something already. So now we know a. So now we know that 2 of the roots of this equation is plus or minus 3 over root 2 times I. So we've finally started getting somewhere. Right. We can then go back. We're then going to know that therefore is going to be 9 over 2 gamma. What have we not used yet? We haven't used the sum of the products in pairs. So remember, the sum of roots in pairs is going to be 3 over m. So we can scroll down and use that fact. So our roots in pairs would be negative ai plus gamma minus ai times gamma is 3 over m. So some of this then cancels out anyway. So we end up with alpha squared equals 3 over m, but we already know that alpha squared is 9 over 2. It's 3 over m, so therefore we can get to m equals 2/3. So now we've got m is 2/3. Once you've got m, we now know m, we now know alpha, so we can sub back in and we can find out what gamma is. So we know what those two things are. They can go into there. So I know that 9/2 times gamma is the same as 9/m. I can therefore find that gamma is 3. So now I've got all the roots of this equation. Once I've got all the roots of that equation, we can go back and start getting our roots of our other equation now, because we had these two statements at the start. So now we know alpha plus beta is 9/2 times gamma. So that's 9/2 times 3, which is now 27/2. We also, if we wanted to find out then from that, we also know that alpha plus beta, using this one, is -3/k. And so now we can use that to find the fact that k is -2/9. So now we know that one. Now we've got the whole of that quadratic equation. It's not difficult now to find our other roots, remaining roots. You could actually do that now by solving the quadratic, or we can now solve this one along with the product of the roots, because now that becomes alpha beta equals 99/2, and we can solve these simultaneously using some substitution, and you can get that beta or alpha is 27 plus 3√7i/4. The other one is obviously going to be the conjugate, so the roots then of my quadratic are 27 plus or minus 3√7i/4. So it's got a little bit messy all over the board, but it's just a case of using all the facts you know about quadratic and cubic roots and just keep writing equations and substituting. The second part then, it wants the roots on a single Argand diagram. Now when they do that, there's a little bit of a hint that maybe you need to get your scale roughly right. So I've got my real and my imaginary roots. So for this, it's probably worth using your calculator just to check. So if I wouldn't write this down, but if you put in your calculator this third, you can find that that's 6.75 plus or minus roughly 1.98i. Oh, 9, yeah. And you can also find out that the 3/√2 is roughly 2.12. And this will then allow us to put these roots in the correct places on the diagram. So the roots of, if we do the roots of g of x first, okay, because they're just going to be on the axis, so we're going to have one there and one there, and then we're going to have a 3, which my scale now has gone different on the real and the imaginary. Let's try and make those roughly the same. So we have one there, and one there. So if I call that g√1, g√2, g√3, and then try and get the other ones roughly in the right place. That means if the third root of g I've put there is a 3, 6.75 should be over here, and also it should be slightly, but not too far, below the other ones in terms of scale. So that one is f1 and f2. So there we go.